Well, good morning, grade 12s, or good afternoon, I should say, Saturday afternoon. Yeah, not a new lesson, so relax, it's not a new lesson. I just wanted to explain one of the questions. One of you sent me an email about this, and yeah, we would have actually done this experiment physically together. I did kind of the microwave versus the kettle versus the stovetop. Okay, so we did that lab together. So this is kind of like that. So they give you some data here. But if you just read the question on page 168, it's a bit confusing. You have to read the paragraph on the page before to get all the information you need. And so I just wanted to explain that to you here. So what I did was in OneNote, I just copied some of the questions here from, the question from page 168. So this is on, I guess I should make a note. This is page 168. Okay, but it's also, maybe I should change that, page 167 to 168. All right, so take a look. It says in this exercise, you'll analyze a controlled experiment in which and I'm going to highlight the important details, a 1.1 kilogram sample of pure water with an initial temperature of 12 degrees Celsius. Initial temperature of 12 degrees Celsius was heated until it reached a temperature of 58 degrees Celsius. All right, so now the deal is this is accomplished with several different types of heaters, okay, and the idea is to determine which one is the most efficient, okay. So here's the data, okay, that's relevant for you. But the thing is that what I highlighted at top in that paragraph, which is on page 167, is crucial. You need that information, okay? Otherwise, you won't be able to answer the question. So here, take a look. Okay, you've got the power, you have the time, okay, here. And so here, I'll do one of them for you. Okay, let's start with the kettle. And well, I mean, let's just do the kettle together. Okay, so here for the kettle. The efficiency is energy out divided by energy in times 100%. Yes, okay, so now if you remember from the lab we did before, the energy out when you're heating a quantity of water is MC delta T, okay? So let's figure that out right away. That's from the data here at the top. So we have pure water, 1.1 kilograms, times 4180 for water. The change in temperature is going to be 58 minus 12. Oh, pardon me. Like that. Okay. So let me just throw that into a calculator. By the way, this step is going to be same for all 5 heaters. Okay. 1.1 times 4180 times 46 is 211508. 211508 joules. Okay. So that's the energy out. Now the energy in for any electrical appliance is just power times time. All right. Now the kettle here, its power is 1500 watts and the time is 173 seconds. So it's 1500 times 173. Whoop. Said it, but I didn't write it. Okay, so it's 1500 times 173 times 173 is 259. 500 joules. All right, so now we have all the data we need. The efficiency then, putting these numbers together, is going to be 211508. All right, I get 81.5%. So it is 81.5% efficient. Okay. And there you go. That's the efficiency of the kettle. Now you can go ahead and do it for the other heaters. Okay. Usually the kettle is the most efficient one. And the reason why is because it's insulated. Okay. It's covered. It's insulated. These things help to minimize the sources of heat loss. Okay. Especially kettles that have an internal heater. like the one that I used here. We got a very high number. In fact, when I did it wrong the first time, we got close to 100%, but usually very high efficiencies for kettles for heating water. It's kind of what they're made for. I mean, you can't really heat anything else in them. They're made for heating water specifically at, fairly rapidly. But it's pretty powerful too. It's 1500 watts. It's the most powerful heater here. That doesn't necessarily make it the most efficient. Okay, you can get a really powerful stove, 5000 watts or something. Doesn't mean it's going to be the most efficient. In fact, it by conduction like that, very much, not the case. Okay. All right. So that is how you do the question on page 168. Okay. If you have any other questions for me, just send them along. I just wanted to explain that to you because a lot of people would miss the data on page 167, Abdi. Okay. I should erase this bracket, yeah. So anyway, you have to read that preceding paragraph and then you'll see the data there. All right, guys, have a good day. We'll talk to you soon.